I will give you a brief overview of three different European projects in which we are involved, and I think with the University of Bologna in all the three projects, and that help as the public administration. I work at the environmental agency, and to manage and to acquire different tools and new tools, and to manage the coastal areas and the environment in general. I start with some information, some data, just to inject a little bit of optimism and to break the ice. This is a picture from the last assessment report of IPCC that shows that how, which could be, and which is the risk, could be the risk related to the global warming increasing. So they have highlighted four different key risks, and especially the fourth one is related to risk to people and infrastructure for coastal, riverine, and fluvial. Okay, here you can see that considering increase of the temperature of about 1.5 degrees, all the different matrices, all the different aspects will be in moderate or high or very high risk with a quite high confidence. Okay, so we have to put attention, because the global warming is a risk for the marine and coastal ecosystem that likely will intensify in future. And this will lead to changes in community composition and biodiversity. And it is stated that at 1.5 degrees in Mediterranean, coastal fish communities are projected to lose about the 10% of species. And if the temperature will reach the 4 degrees, instead the loss will be of about the 60%. Then we will have an increase in marine heat waves and the related risk for species, biodiversity, ecosystem function, and services, of course. And also ocean acidification and biological and ecological risks are projected to rise, as well as the decrease is projected, the decrease of the marine primary production, with rates that range from 0.3 to 2.7, depending on the temperature. This is the effects of the increase of the temperature. Looking at the sea level rise and focusing on the Mediterranean, of course, we will have a dependency by the emission scenario that we will consider. Just to have some numbers, we have to take into account that during the 20th century, we recorded an increase of 1.4 millimeters per year. But the problem is the acceleration that we recorded during the last decade. So from 1993 to 2012, the increase has been of 2.4 millimeters per year. So, this graph shows the projection of sea level rise, and we will see that we can range in 2050. We have a range of that goes from 0.15 to 0.33 meters. Instead, if you look at the 21st hundreds, the range, the spread is higher, is wider, and we can range from 0.3 to 1 meters and over. with all the impacts that it means. So we will have strong impacts on the agriculture, fishery, aquaculture, urban development, forestation, and so on. And then finally, which could be the action, the adaptation action we could take, and we have to consider in order to contrast the effect of the climate change. Okay, we have some, how can I say, some frameworks for the environment. The first one is the integrated coastal zone management, and we also have the marine special plan. They are, of course, some sort of regulation. There are good practices to follow, and even if they don't specifically mention the climate change inside them. But of course, there are good practice, good management operation to follow and to adopt and to enforce for sure. Then we can obviously adopt green adaptations, ecosystem-based adaptation, and nature-based solutions as adaptive management strategy that facilitate coastal flood protection and generate benefits beyond habitat creation. From the report is highlighted that we have to empower, to reinforce, to increase the number of marine protected areas, especially the non-permitted uses marine protected areas, because they provide protection for local stressors such as commercial exploitation, and they enhance the resilience of marine and coastal ecosystem. So it is, there are so far a very low percentage. So we have to take account that no-take areas are accounting in total for less than the 0.4% of the European waters. So a suggestion is for sure to increase these areas. So climate change, integrated coastal zone management, marine protected areas or Delta 2000 sites inspired a number of projects in which we are involved. Now, let's focus on the Emilia-Romagna. I work in a regional service, so we are focused in our region for the most of our duties. Which are the characteristics of the Emilia-Romagna and the vulnerability and risk factors? So we have 130 kilometers long coast that is characterized by the large areas of coastal plain below the mean sea level. And we can record a natural and anthropogenic subsidence that it's, I think it's mean value of 3 millimeters per year, but in locally can reach rates of 15 and 20 millimeters per year. So it's a strong subsidence process. Coastal dunes are still present, but less than the 30% of the coastline. And the frontal beach are generally low, and the 52% of them has a mean height lower than 1.5 meters. Our coast is subject to beach erosion and seabed lowering for half of the coast. And another key issues to be taken into account is the anthropic pressure within the 300 meters wide coastal strip. And in fact, we recorded over 400% in 65 years. So it's a very high urbanized area, and this high urbanization increase, of course, the exposure and consequently the risk of the coast. From a long-term study starting from the early 80s, early 110 for the shoreline and 1900 for the bathymetry, we can see that there is a general straightening process of the coast and a subsequent river mouth dismantlement that has been recorded. This process is mainly depends on the sediment lacking that is mainly due to the reduced bed load from the river. This is a future scenario. This is a study that was performed by the region, a simplified model, but according to the flood directive, they had to produce inundation map. And for this reason, they consider the sea level rise stated by the previous report of IPCC, integrating and consider also the subsidence together and the storm surge, the effect of storm surge. This is just a zoom of a map where it is possible to see how consider the P2, that is the low frequency storm at 2100, we can see how the violet area can affect our coast, and how the flood, the potential flooded area will increase in the next year. For the worst case scenario, the floodable area will increase about the 3.5 times with respect to the present. But the thing that I want to highlight with this picture, but especially with this number, that if we consider the rare event that is a return period of about 100 years, we will have an estimation, a projected floodable surface of about 80 kilometers square, but we have to consider that 22 of the 80 are urban areas. That is, it is really a risk that we have to manage, and we are a little bit late. So, adaptation plans, coastal risk, and coastal management. These are the keywords that inspired the first project I want to talk about to you now. It is called AGRACLIM, that stands for European Project Supporting Coastal Adaptation Strategies in Adriatic Basin. It's a project that we are leading. The partnership is composed of 19 partners, 14 Italians and 5 Croatians. It's a 3 years long project for a budget of about 9 million euros. And the strength of this project is the strong collaboration among the local and public authorities, together with research centers and the university. And in fact, this project had a strong scientific working group, University of Bologna, CMCC, CNR, Ruder Boskovic, Eisler, and someone else, that collaborate for developing accurate information for the promotion of regional and local plans for adaptation to climate change through new information, new and more local, as I could say, information. The report of IPCC are okay, the Mediterranean is just a pixel spot inside the results of IPCC. What we want to do is to downscale this information to the local dimension, okay? So how to do that? Through the development of new modeling methodologies that are integrated together with observation. So, and lastly, we want to develop the new interface, a new platform that will give the local authorities that plan the policy maker the access to the information in a more easy way than today. So I talked about the modeling activities. This picture is from by Giorgio Berri from CNCC that collaborate together with the SINCEM laboratory of the University of Bologna, and they are setting up a new modeling change that range from the downscaling of the atmosphere and the ocean global fields to the local ones in an integrated way. So we have a fully integrated modeling change of the atmosphere and hydrology through the WRF model that will force the circulation, the ocean model of the Adriatic and the waves and the geochemistry, sorry. This is our area, and this is the domain of the regional model that they are setting up. The historical and the scenario we will simulate are this one. The climate simulation will be of the projection will be of the 2021-2050, but at a resolution, a regional resolution of 2 kilometers. That is really challenging compared to the global simulation we have available so far. Okay, so but it's not finished. We want to further downscale this information to a sub-regional scale, so to a regional in terms of Emilia-Romagna, Veneto, Friuli-Venezia Giulia, Puglia, and the Croatian coast, for the local models in order to have even more accurate indicators and information in order to develop local adaptation plans. Unfortunately, the length of the project it's not so long to cover the process, the bureaucratic administrative process that a plan needs. And for this reason, here in Emilia-Romagna, we are going to we are drafting and we are going to issue a strategy. It's not exactly a plan, but it's a strategy. It is called the GDAC, Integrated Management for the Protection and Adaptation of the Coast to Climate Change. So we started in 2020 and with a regional working group, and through a process that has seen also the strong participation of stakeholders, citizens, and university and research centers through the participatory process, we arrived to have a strategy that was published for the public consultation. Now I received an email the last days that the public consultation is finished, and so they are waiting for the newest indicators, outputs of the AdriaClean project in order to update the information they have, and they and that they consider in order to take action, not to take action, to suggest action for the management of the cost. So we are now at this stage. So this is the project. Okay, not just another slide. That there are 4 inspiring issues of the strategy. There are 4 guidelines and the relative objectives for each of them. So free up space and maintain a beach free from structure and infrastructure. This is done for reducing vulnerability and risk exposure, enhancing resilience. To ensure an adequate supply of sediment to coastal system. Okay, so feeding the coastal system, since we are in erosion, we need material, and that is what we do with nourishment about every 4 years. But of course, if natural sediment transport is preferred, of course. Promote the integration of cost benefit and coastal dynamics risk factors assessment within the decision-making process. So decision-making coherence in relation to environmental and risk conditions, and maintain and further develop the knowledge system. So the objective, of course, the knowledge framework constantly updated, because sometimes what is lacking, especially for the sea and the coast, is the data and the knowledge. And data is something that within this project we are trying to enforce, investing in new observation networks. With Agraclean as example, we are investing in a new wave buoy moored in front of Cesarnati municipality that will acquire data about waves and currents. So, and okay, I will talk a little bit later about equipments. So monitoring system in terms of observation and modeling and adaptation plans, collaborating and integrating different knowledge and know-how. I skip to the second project I want to talk to you. It is STREAM, Strategic Development of Flood Management. We talk about how to manage the climate change, but how to manage fluvial and coastal floods caused by extreme weather and severe sea storms. This is the inspired issues, the key issues of STREAM. This is a picture of Lido di Savio during a coastal floods in 2015, the 6th of February 2015. So you can imagine that the problems that severe sea storms can cause to the urban area, coastal urban areas. STREAM is led by Zadar, that is not Zadar country, but an agency of Zadra. 16 partners are involved, 9 Italian and 6 Croatian. And also in this project, there is a strong participation and collaboration among research, science, and local authorities, so research and university and local administration. The objective of STREAM is to reduce human and socioeconomic losses in case of flood hazard by improving flood risk management and local authority and emergency services with a cross-border approach. In this project, we strongly collaborate with the civil protection, the regional civil protection agency here in Emilia-Romagna, and also with the region, because we are mainly focused on the coastal risk management in terms of civil protection system. So we have been the first region in Italy, yes, to have a specific session into our civil protection alert or bulletin in Italy, and we have a fully operational early warning system. Luis Biolchi will talk better in the afternoon about this. And so now we are collaborating together with the other partners to integrate the information and to empower this early warning system. In general, the objective of STREAM is to develop an iFlood platform that is an online international platform to collect shared data floods in the Adriatic, a flood forecasting system for the entire Adriatic-Ionian area that will be a wave modeling system and a multimodal forecasting system for the Adriatic. And then to continue developing the early warning system to support the rescue and management in case of floods. In Emilia-Romagna, what we are doing, we are moving toward a different concept of providing forecast. So far, we are used to have forecast, deterministic forecast. So to know exactly, we expect exactly 101 indication. We are moving, since this is also mentioned in the new national regulation of civil protection, to provide forecast also in terms of probabilistic information. So we are trying to adapt, to move from a deterministic early warning system to a probabilistic, a semi-probabilistic one. So to provide information about the uncertainty that is connected, related to the forecast we are providing. This was the object of a Wacoma student, Luis, that is now my collaborator here at the Arpai, and we are continuing working in this, try to apply ensemble techniques to the coastal early warning system. The second modeling pilot we are performing is the Po Delta pilot. That the Po Delta area is a very particular and fragile area to be studied and to be considered. So for this region, we want to integrate the hydrological information and forecast we have together with the Ocean One, also in terms of multimodal ensemble or probabilistic forecast. Okay. Concerning the observing systems, thanks to the STREAM project, we are implementing a new webcam network for the Emilia-Romagna, for the entire Emilia-Romagna. Now we are focused mainly on the coast, and we are going to install about 9 or 10 cameras along the Emilia-Romagna coast. But what we are trying to do is to set up a network, a system, so that we will be able to add additional cameras in future, and so to monitor exactly what will happen, as example, during a sea storm or a river floods. Okay, so this is important because most of the cameras are private cameras, and there is not an institutional network in this sense. The other instrument we are going to install with Stream are two type gauges, one in Cattolica and one in Cervia, coupled, integrated with permanent GPS, GNSS, that will help also to correct the measures, take into account the vertical variation of the ground. Okay, these two type gauges will complete our type gauge network, since we already have a type gauge in Porto Garibaldi that is operational since 2009 or something about 2009. The last activities we are doing with the Stream is the training of municipal administration, stakeholders, citizens, students, and so on. Because training and information, we have to keep in mind that is an important fundamental element for the risk reduction. We all know that, risk is the composition of hazard and vulnerability and exposure, but there is also another terms at the denominator of this formula that embrace all the action that we can do to mitigate the risk, and training is one of them. It is really important, and so we decided to work with the municipality of Comacchio. We had some laboratories with them, different laboratories with municipal administrators and stakeholders. In autumn, we will do some training and we'll spend some time with students with an educational activities. And in the next spring, in 2023, we'll have the second civil protection exercise on the coast. The first one was performed during the Iceland project. It was the first one that was performed in Italy, the coastal exercise, and we will do the second one. And useless to say that civil protection exercises are fundamental in order to have and to keep in mind to have also to keep all the procedure in mind and to let the workflow and the flow of information work fine. I write to the last project Cascade. We are talking about management, we are talking about climate change. Now we are talking about ecosystem. Cascade stands for Coastal and Marine Water Integrated Monitoring System for Ecosystem Protection and Management. The objective is to increase the marine knowledge through the consolidation of inland and marine waters monitoring, so observing and modeling, again, tools. In particular, Cascade will contribute to the biodiversity protection in several Natura 2000 sites, so remember protected areas, so this is something that is related with. Also providing monitoring tools, best practices, restoration, the restoration of endangered species, integrated management plan. This is the partnership, 16 partners, 10 Italian and 6 Croatia, plus 4 associated partners. Again, collaboration between science and local authorities, and focusing on 11 pilot sites. Here in Emilia-Romagna, we are working together with the University of Bologna and Delta 2000, and our pilots are, the coastal area of Emilia-Romagna in general, but in particular, we have 2 spots in which we are working stronger. One is the Sacca di Goro, and the other one is the Bocca di Bevano. Okay. University of Bologna is collaborating with the Laboratory of Algal Biology with the assessment of ecological status of the ecosystem and the vulnerability. And with another laboratory that is the Ecology, Conservation, Recovery of Coastal and Sea Environment, that is working mainly with the sampling of benthos and evaluation of extreme impacts on the benthic ecosystem. As ARPAE, in collaboration with the university, CNR and CMCC, we are developing a new modeling systems of the Sacca, sorry, there is an animation, of the Sacca di Goro, the Goro Laguna. This is the project, a PhD project of Jacopo Alessandri, that graduated the last week. This was the project of his PhD thesis, and he set up this very high resolution of the Goro Laguna. Here you can see some data, but which are the aim of this new modeling system? We are using the unstructured grid model, it is called Scheiben, that help us to define better and to detail in a better way the complex geometry of the ground, of the land, okay? This model will be coupled together with the biogeochemical flux model, the BFM, for the marine ecosystem modeling. Thanks to this model, we will be able to perform some what-if scenarios for a better and more appropriate internal management and planning of the Goro Lagoon, and also to have more accurate storm surge forecasting for a coastal risk management. So finally, the coupling with the Po River hydrological model will help us to better evaluate also the south wedge. So you can see from this issue how it is important to work with very local modeling system in order to resolve properly the physics and to have the information that the local authorities, they have to manage the cost, they have to manage risk, and they have to manage the risk need such kind of information. Information, observing systems. I'm arriving to the end of the presentation. We are going to install a multi-parameter station in Podigoro in order to characterize the fresh water that will arrive in the Goro Lagoon, and we will integrate multi-parameter probes and sea level inside the Sacca di Goro. Finally, stakeholder involvement. Sorry, I had some familiar problem. Stakeholder involvement, we had a day, we spent some time together with citizens and local authorities during the 2nd of July, and these events are important. This is the Adriatic Seaside Festival that embraces a number of events along the Adriatic coast. I'm arriving to the end. So, from our experience and the development of this project, what is important, in my opinion, to stress and to highlight? Integration. Integration is a keyword. Integration means that we have to integrate the modeling system and observation and measure, but we also have to integrate different environmental components. We cannot think only to the ocean, only to the atmosphere, only to the rivers, but we have to start thinking, integrating all the information together, because the environment is a continuous, not a discretized element, okay? Integration of different background and knowledge. This is important in order to let the watch run properly, okay? We have different elements that you have to be integrated in a proper way. So different background and knowledge leads to collaboration. Everyone on the canoa have to paddle in the proper way, in the same direction, if we want to reach our goals. So collaboration between research and science, collaboration with public administration, stakeholder, and citizen. This is really a value of this strategic project in which we are involved, and I really thank to be part of that. And I think that is really something that we should keep in mind and try to use more often than we are used to do. So I want to finish, just to summarize, to mention Prof. Elliot be an apple pie, not only from a singular point of view, but also in terms of the system. A system, and I think that it's not for pleasure. It's really my thought. I think that Wacoma, this is the picture from the agenda, the online agenda, and I think that summarize all these aspects, so integration and collaboration. It has been for me a pleasure and an honor to be part of the Wacoma, and I think that Wacoma expressed exactly this concept. Okay, thank you very much.
Okay, thank you, Dr. Valentini. Important messages and a lot of information. But I apologize. I have to say that we are enormously over time. And then I have to cut the question session and also change the plan for the morning. And I already asked Dr. Tegan Blount to speak in the afternoon because we have no time enough. So this would suggest us to the speakers, every speaker, I'm not only telling this to Dr. Valentini, but to keep the time. Otherwise, we are obliged to change our schedule, and we and ask to other speakers to cut their time. I don't want to do that. We assign specific time, so I apologize for the change in the program, and we go ahead with Dr. Eduardo Ramirez Romero from CSIC, Spain. You're very welcome. Please. And I thank Tegan for the patience to speak in the afternoon. And yeah, so Eduardo Ramirez Romero is from CSIC, Spain. CSIC is the equivalent of our National Center of Research in Spain. So it's an important institution which has been partner of Wacoma. We are very honored to have you here.
Ciao. Can you hear me? It's okay? Thanks a lot for your invitation to this inspiring city and symposium. I'm Eduardo. I'm doing this work with some colleagues from Marbec, from Montpellier in France. My topic, or my work here I'm presenting, is focused on jellyfish, and the title is Towards Simulating the Role of Jellyfish as Indicator of Change in Plankton Food Webs. I'm focusing here on gelatinous zooplankton. You know this group, it presents massive blooms and swarms. And this bloom has also several impacts on socio-ecological system. Some of them are not harmful or bad, like jelly fisheries is a rising topic also right now, but most of them have a negative impact on human activities, as tourism, fisheries, aquaculture, or even power plants, because the jellyfish clog the refrigerating system. Within gelatinous zooplankton, we have different taxonomic groups: Urochordata, mainly salps, ctenophores, but most of blooms are Cnidaria or Scyphozoa, like we call it true jellyfish. Okay. Here in the Mediterranean, we can find these jellyfish species. All of them are Cnidaria and Scyphozoa. Some of them are stinging, like Pelagia, you know, probably. But we have several species. There is also, we know, or we have some insight about a rising trend about jellyfish bloom, and drivers are usually linked to a huge array of drivers. It's a very complex pattern because most of them are related and acting at the same time. So we have global warming, overfishing, eutrophication, ocean sprawl, and human-mediated introduction, like invasive species. So most of them are actually acting at the same time. Jellyfish seems to be a not very complex organism, like a jelly thing, but the life cycle of jellyfish is not so. It's really complex. So they have a benthic stage, like polyps, as Cnidarian they are, and polyps are fixed in hard substrate or the bottom rocks everywhere, and they have a sexual reproduction there, different processes like estrobilation, gemation, and then there is a release from these polyps to the water column to individuals like Ephyrae, like a kind of larvae of jellyfish. They start to eat, they grow, and they become medusa, which is the sexual stage, and they have like a sexual reproduction. They produce eggs and larvae, like planula larvae, and these larvae go again to the bottom or to hard structure to close the cycle. This is rhizostoma. I will talk later. So my first aim with this was to add or to include jellyfish within planktonic food webs. First efforts focus on Aurelia aurita, this moon jellyfish or this jellyfish, also very common here in Europe. And the food web models, or classic food web models, used to call NPZD, which means nutrient, phytoplankton, zooplankton, and detritus. And we include a new compartment, jellyfish, or in this case, Aurelia aurita. We simulate a stage-solving model with two stages, Ephyra and Medusa, and also we include, so we could simulate population dynamic and biomass, so biogeochemical cycle and population dynamics of jellyfish. Each stage has a different metabolism, different parameterization, and also they have different trophic level, or let's say they have a different diet, which is the main point here. Our first try was modeling this food web of Kielbait, or a shallow ecosystem in the Baltic Sea. So we develop a 0D, a box model, let's say. It's only the food web. And we include different functional groups trying to cover several environmental niches. So this is the food web of plankton here in the Baltic Sea. We include two groups of phytoplankton, diatoms and flagellates, microzooplankton, a ciliate, mesozooplankton, a copepod, and then Aurelia, Aurita, which the jellyfish with 2 stages. So we simulate like a ventis release. We put an initial amount of individuals. With these arrows and the strength and of these arrows represent more or less the diet of the preference of each group, which is also interesting for us. A plankton model sometimes seems to be a very abstract thing, but more or less here I would like to show how it works. We have a group, for example, phytoplankton, which is an equation in the model, and we have some input and output, positive and negative term, or input or losses. So they grow, they have respiration, mortality, predation. So more or less, this is how it works. And the same for all the groups. We have each processes is described by a parameter, by some parameter and some equation. Then a very key process in modeling, validation. Compare your model with in situ data, with the reality, with the nature. So in Kielfjord we have, there are classic feature of seasonal cycle in cold and temperate waters. A spring bloom of diatoms, then a peak of copepod, and then during summer, jellyfish. The model could capture these main features. And also we tried, we checked the model in another condition with different amount of jellyfish to check how the food web will respond under this, and we could also capture the different, for example, jellyfish deplete copepods. They eat everything in the food web. But then we moved to an open science approach. We translate the initial code in MATLAB to R, and we are developing an R package. It will be open and available. And the final aim for us will be to put it available, and so you can use your own ecosystem and your own jellyfish and adapt the code, which will be, I think, not so difficult. And we adapt the initial model to Rhizostoma pulmo in the Mediterranean. So why? Rhizostoma, probably you know, is widespread here. It's, this species presents massive blooms also in the Mediterranean waters with really outstanding biomasses like this. And we adapt, as I said, the initial model to a Mediterranean lagoon. Actually, it was in France, close to Montpellier. And we include this new jellyfish. More or less, the food web is the same groups, but we have different stages of Rhizostoma here with different diet. And this is also interesting because they don't have an overlap in the diet. For example, young individuals, they are more carnivores, they eat copepods, but adults, they feed on flagellates or ciliate, more microzooplankton. So more or less, this is how the jellyfish model works. It's pretty the same. Of the rest of the compartment, we simulate an initial release of individuals to the water column, and they started to grow, to feed on other groups. When they reach a threshold of biomass, they move to one stage to another one, and they have different parameters of these processes. We could also simulate different periods of release to the water column. Like here, the word is like a strobylation event. About validation, we simulate 3 inputs of individuals to the water column. And then we capture the order of magnitude of the blooms and the seasonality of the peaks, which is the strategy of this species. So now we are happy with the model, and we are more or less confident, so we will go further. But what I find really interesting about this modeling, you can set numerical experiment to check hypothesis. In this, with this model about the Baltic Sea and Aurelia, we check some hypotheses. For example, we set different, or we ran different experiment, and with an increasing amount of individuals to the water column, and we see how the food web we assess the food web response. So with an increasing number of jellyfish, there is a decreasing number of copepods. So we assess a tight top-down control of copepods here, which is also relevant because copepods are the main food of fish larvae in this ecosystem. For example, herring used to go to these fjords for the spawning, so they will compete, and even they could feed on fish larvae. And also, there is like an interspecific competition pattern, because the more jellyfish, the smaller one they are. So this also will affect the quality of the spawning and the quality of the eggs they produce for the next step. Like this, no? But we would like in the next future to go further with this modeling, using the same. This is only an example. Using the same food web and the same model, we could set scenarios. Here, for example, the effect of global change, combining both climate warming and eutrophication, or even restoration actions. So you can imagine with more, we could set this kind of scenarios and see how the food web, to see the response of the food web. So with more, for example, a very straightforward pattern with more nutrient and more biomass, we could find more jellyfish or more biomass of jellyfish. But it's not always straightforward, for example, for copepods. Even you could assess, or you could set scenarios for competition between different species of jellyfish. So in the next future, I would like to explore these topics. Finally, to sum up, the skills of this approach, in a reasonable way, we can capture the dynamics of food web lagoons in a 0D approach. This approach is quite flexible and simple. You can add more compartment, If you have another species of jellyfish, you can adapt the model. It's really fast to run a simulation like this. It's a couple of seconds. So you can try, you can play with this. And we found some emergent properties and for checking or testing hypotheses, even to assess ecosystem or regime shift or tipping points in your ecosystem. It will be very interesting to check this. But on the other hand, the limitation of the model, not all ecosystems are a box or a lagoon. We have advection currents. So this is a main limitation here. If the model is really complex, you can use several parameter processes, so the uncertainties associated rise a lot. You have to do a proper sensibility analysis of your parameters. And also validation, you need a good time series covering different trophic levels. So in situ data is really crucial here. And finally, the benthic stage is a problem for us right now because it's really hard to find polyps in the water column and to assess the dynamics of all the processes involved in these polyp processes are really hard to find in the field and to also to simulate. So we have this gap right now. And many thanks for your attention.
Especially for bringing here the word bicycle, which is of course an important body we have had as a partner of Wacoma. So thank you very much. I think we have the opportunity during maybe the lunch to ask questions. I'm sorry, but so we try to keep the time. And well, thank you very much again. And I invite then Enrico Sassi, sorry. He is a friend of us, of Wacoma, because he has been, he represents here Lighthouse, which is a company which hosted already students for Wacoma in the past. Amina, I remember, for an example. And he also was without for the conference in Cardiff. So thank you very much to be on our side.
Okay, thank you. Thanks for inviting me and representing Lighthouse to this symposium. And that's very important to have this opportunity because we talk about a very relevant argument for the protection of the environment. I will keep this shortly because we start the morning talking about apple pies, so we are crossing close to the lunch, so I will try to squeeze as much as possible because I hope you will appreciate this. Brief talk about Lighthouse. We are a leading provider of high-tech service solution. So we are providing services. One of our key points is to be able to provide tailor-made service solution to our customer. I would like to emphasize the fact that we work on tailor-made solutions, service solution, because it is exactly what we are going to talk today. Basically, we in Lighthouse, we do geophysical survey, we do environmental survey, a few geotechnical survey. We support our customer during construction, using for precise positioning and support to construction. And we also do, that is the most important things, data processing and interpretation of our data to the customers. So basically, we collect data, and everybody know how much is important to provide and to feed the information with reliable data. So the talk of today and title is Present and Future Developments of Autonomous Surface Vehicle to Support Coastal Survey. So there is something that is going to change. We are all obliged to match the target to net zero. It is set for mid-century. So this somehow has to affect our way to do survey. So we are going to talk about what are the progress, what is the present, what would be the future for these techniques, especially for what concerns the coastal areas. So basically what we are talking about something that is conventional versus something that is unconventional, something that is manned, you see man here acquiring data, versus something that is unmanned, like this, tethered versus untethered, controlled versus autonomous, gray versus green. And in our environment, we love a lot the acronyms, okay? So we talk a little bit about acronyms. We talk about AUV, that are autonomous underwater vehicle. This is a UGIN 4500 that we have in our company. Basically, our autonomous vehicle that works undersea, underwater. Then there are autonomous surface vehicle or uncrewed surface vehicle that works on the surface. And then there are relative recent development for MAS that are marine autonomous surface ships. We are talking about something that is used for transport, materials, and so. And there is a lot of development for what concerns the underwater vehicle. More recently, there are more recent development for surface vehicle. The history, there are development of autonomy or green or different power to the vehicle starting from the end of the last century, 18th century. They were powering the vehicles using electrics or using the waves. What are the advantages of these autonomous vehicles? And they are unmanned, may afford, as we will see later on, longer and more hazardous mission, and possibly at low cost, possibly more safely. So this allows shallow water survey more accessible. That's important for the coastal survey. The more recent history, only 10 years ago, we were talking about semi-autonomous vehicles, and with a lot of challenges for what concerned the fully autonomous vehicle. Why? Because there were not all the technologies to afford the fully autonomy solution. Only recently, artificial intelligence, machine learning solution, deep learning solution, development of automation, communication improvement have made possible fully autonomous application. Now we see briefly what is developed, okay? Probably there is more behind this. We start from vehicles that use endless ocean energy sources, basically the wind, the solar power, and the waves. This is Sailboy. This was tested as a pre-commercial solution at Oceanic Platform on the Canary Island. This is a wave glider. This is quite interesting stuff. It means it rely on the waves movement, on the rotation on the waves. There is a submerged payload that followed this and allow the vehicle to transit to cross the Pacific Ocean, so something that works for a long distance. Out and out similar, use the waves movement. Is mainly used for mammal monitoring, marine mammal monitoring. The sail drone, probably you listen about this sail drone recently, this vehicle that use solar power and wind have crossed in hurricanes and provides images of the hurricanes starting from inside the hurricanes. Something interesting, sails drone has also sails for more than 180 days in mission, so something very, very extreme. Mayflower, this is developed by IBM. A lot of money they are involved in this. It's a quite strange vehicle, but just worked a few for a small transit, but it's really challenges. Sphere, this vehicle focus on passive acoustic monitoring of the sea. And one of the first commercial application of the vehicle is this X-Ocean that is powered by the solar panels, and it has been used for mapping for commercial survey, what we do every day. Then there is this submarine. This vehicle is a hybrid vehicle, so may stay on the surface, and sometimes it goes down the sea as a glider. So basically glide underwater columns and collect information about the water column. Then there are, in parallel to this vehicle that use fully independent and endless, let's say, energy from the ocean, there are vehicles that have hybrid concept, so use at the same time natural energies and then are powered by, hydrogen or fuel, diesel, and whatever it is. One of these vehicles is this Drix, okay, and this is a vehicle that is has application in the commercial market. SeaKit, this is also a vehicle that has more than one function and is powered by diesel, and now they are attempting to power this by hydrogen. And then Ocean Infinity Armada. This company has a lot of money, and they are investing in a huge fleet of autonomous vehicles. And so, recapping, the big question of the days are, can autonomous unmanned low-emission vehicle allow reliable data acquisition with ambitious target to work 24 hours a day, 7 days a week, 365 days in a year in all sea conditions? This is really challenges. In fact, there are a lot of challenges. Any challenge has a solution. So this is why there is the progress. So first challenge, vehicles payload. More payload you add to the vehicles, more battery capacity you need, okay? Second challenge is more big is the size of the vehicle, there are involvement of the safety of the vehicle, because we are talking about the vehicles that are on the surface, so there is interaction with other vehicles. Then you have to rely on reliable communication, and we will see later on why. Sorry, come back, okay? And then we have to rely on reliable guidance of the vehicle, because we are working in something that is unpredictable, is unstructured. We are not moving the vehicle autonomy on the street with a plan. We are in open sea, or even a worse situation close to the coast, where the environment is even harsh than offshore. And we need also challenging naval design, because we have to combine a lot of things in small pieces. And then there is the need to be green for spatial propulsion. So there is a lot to talk about. First things, the payload. So we need this vehicle because of the payload. The scope is to collect reliable data. So we have to focus on how much is important what we bring with ourselves to have our proper investigation. So scope, bathymorphological service, multi-beam echo sounders, side-scan sonar, stratigraphy, subborne profiler, metallic object detection, unexploded ordnance, everything we can find on the seafloor, the debris, archaeological study. So, for instance, presence of magnetometer, even imaging in this case. Also environmental sensor, methane sensor, CO2 sensor, wind speed, temperature, wave height, a lot of things we can carry on this vehicle. And we also have advantages. We are on the surface, so we may also mount over-the-horizon sensors like LiDAR. So we have a combination from with subsea and submerged, emerged and submerged information from the vehicle. What is the matter is that the payload drives the size. If I have to put a lot of things on the vehicle, I need a biggest vehicle. At the same time, the sails and the pilots require power. So there is a matter of fuel endurance. Two examples. So there are vehicles like this one that have sails for more than 180 days in the ocean, but with reduced payload. There are other vehicles like this one that has worked for up to 30 days in autonomous with a reduction of 95% of the carbon footprint of the vehicle itself. So there is a combination and a balancing between the payload, the size of the vehicle, what I have to do, and the power of the vehicle. The important scope, we talk about a tailor-made solution. So what we have to do? What we have to do is to record reliable data, in bracket, but last but not least, low emission, affordable cost, and a safe way. So since the vehicle are developed for that mission, we have to consider that the longer the mission is, the larger is the volume of the data we collect. And if the vehicle has to stay weeks offshore, months offshore, the amount of data we have to transfer to shore is large. So communication are fundamental for this scope. At the same time, not only for the data, here we have some example of data we have collected in deep water using an autonomous underwater vehicle. Consider this, we are talking about tens of kilometers square of data with a data for the bathymetry of 1.4 meter. And considering the morphological imaging, thanks to a synthetic aperture sonar, there is an information every centimeter. So we are talking about huge quantity of data to be transferred to shore. Not only the data is important for the data is important for the communication. Communication needs also to provide feedback from the vehicle to the shore, because we have to monitor the field. The vehicle cannot stay alone offshore without control. So we have to control the vehicle from remote. And so the vehicle communication has to provide adequate situation awareness. So one of the biggest challenges is to demonstrate that the vehicle and managed system is at least safe as manned ship systems are. Okay, this is a typical case. We have not only to plan for a mission in a way that we follow parallel line. We may also to plan for the vehicle that for the mission where may cross another vessel, or may skip a buoy, or may avoid an obstacle. And in certain cases, we have also to keep control of the vehicle, because the vehicle has no solution. Artificial intelligence on the vehicle has no solution. You have to keep control of the vehicle and to take the mission under our control. So the communication is important for the data and for the safety of the vehicle. And for the data, so to have reliable data, especially on the coastline environment, we need a special ship design, because the vehicle has to be stable in the water to provide low noise data, okay? So the shape of the vehicle is quite important for the payload. So sometimes we need sophisticated and challenging naval design, but sometimes the simple solution meets the scope. I need just a small vehicle with a bathymetric system to collect the information on the bathymetry, or I need a small vehicle with, let's say, an environmental sensor to collect just this information for my scope. Then, finally, we have to make them green, okay? So not only reliable data, but we would like to have also low emission. These are some sentences taken from the website, where people declare that they would like to have stable, low-emission hybrid platform with a certain equipment on board, able to reduce 95% the carbon footprint. It's challenging, it's important. And there are also attempts to change from a completely diesel-electric propulsion to an hybrid propulsion, okay? Mixing the two things by simply replacing one diesel engine generators with new hydrogen fuel cell technology. The scope is to demonstrate that an offshore operation with zero carbon emission is possible, is feasible. So how to make them green? Okay, this is a recap on what we may have as a power on board of this vehicle. Maybe this diesel power, so this is like a vessel, a normal vessel, may allow endurance by days. Okay, weak point or challenges, absolutely no green, and need to refuel. So this vehicle has to return home sometimes to refuel the diesel, and the diesel is not green. And advantages, because there are advantages. We cannot take care of the size, can be big as much as possible, and also the payload is unlimited, theoretically. Then, on the other side, there is fuel electric conventional batteries. Our vehicle, the Hugin 4500, can dive to 4,500 meter water depth, so full ocean depth, as a battery pack, may work for 30 hours independently, autonomously, may collect all the data we have talking until now, so all the geophysical payload, magnetometer, images, CO2, methane, oxygen in the water, everything, temperature, currents, everything. So payload size is not a problem in that case. And, but the battery are charged using the power, so mainly fossil fuel. So let's say is alpha weight green. It's alpha weight green because we can stay with a vessel with low speed and the vehicle can dive, reducing the consumption of the speed. But the power we give to the vehicle is made by fossil fuel, at least up until now. And also the endurance. Okay, 1 day, close to 1 day endurance for this kind of vehicles. Then there are totally green power, what we talked at the beginning, endless ocean energy sources, vehicles that are moved by the waves, by the wind, by the solar panels. They can stay offshore months, okay? But payload is limited, and energy sources, especially close the coast, is not so controlled. It's controlled by local condition. When you stay offshore, in the middle of the ocean, the conditions are more constant than close to the coast. Close to the coast, the condition of the sea, wave heights, speed of wind, direction of wind, is going to change continuously. So in the coastal environment, this kind of vehicle probably are not the best. But for sure, advantages, fully, totally green, and the endurance, days and days and days offshore. Then there is a mix about diesel and battery. So we're talking about hybrid vehicles. The endurance may be elongated for days, okay? There are limitations due to the battery capacity, okay? There is a limit on the battery capacity, and also the recharging methods. Recharging methods may still rely on carbon fuel. But the vehicles that are 2 days on the market have provided 95% reduction in the carbon footprint. And this vehicle have no limit on the payload. Then, finally, there are possibly different kind of battery. So the battery, there are fuel cell, hydrogen fuel cell, okay? Could be pure H2, okay, pure hydrogen, or ammonia. Okay, endurance is days, because this vehicle, this battery can bring a lot of energy in. But there are some weak points or challenges. The charge of the hydrogen is complex, and pure hydrogen is difficult to store. But for sure, there are green, okay? The payload has no limitation, and a recent study says that ammonia is less complex than hydrogen, because ammonia can be stored at only 10 atmosphere and at a temperature that is more reasonable than the hydrogen. Hydrogen requires 100 of atmosphere, and also the temperature is minus 200. So it's really, really, really difficult to store. But ammonia has only 10 atmosphere to be stored and reasonable temperature. But the production of ammonia is still gray-blue. So the production of ammonia is not easy like it's not so green at the moment, but development are in due course. So I have keep it really short. I hope you have appreciated this. So I thank you for the attention. My name is Enrico Sassi. This is my email. If you want to drop me email, make question, or apply for your for your job application to Lighthouse, it is welcome. Thank you.
Okay. Thank you, Dr. Sassi. And yeah, I think all of us are excited for these toys. And probably, well, again, we have no time to do questions now, but we have the lunch. And probably the main question will be the price of all this, because we are all excited for these toys.
I know the price for the vehicle we have, talking about something in between 5 to 6 million.
Okay, so it's too much for us, you know. We are poor people. Okay, so. Yeah. I would suggest you youngs to apply to Lighthouse and go there for a job, and then have the possibility to use these tools, these toys, I would say. Okay, So let's go for lunch. I apologize again for the delay, and then we have to maybe to short also the lunchtime and the poster session. But I invite all of you, especially the hosts, to visit the posters, because this has been an effort also by the students, and they illustrate in the poster their activity. So there may be the possibility to ask questions and to go deep into some concepts. Thank you very much. See you at, then we take the time for the afternoon, 2:15, and we try to be more on time in the afternoon session. Thank you very much.